Hello, class. This is the end of Chapter 7, or 7B, since I called the first one 7A. We're going to finish up the pre-algebra sections and the algebra sections. Today we're going to solve simple equations. Now, arithmetic equations such as this, 3 plus 2 equals 5. That means that the number on the left, 3 plus 2 is 5, and it's equal to your answer 5. So those are just equal to each other, okay? An algebraic equation would look something like this. X plus 3 equals 7. Now this is a statement that the sum x plus 3 is equal to 7. If we choose the correct value of x, the number x plus 3 will be equal to 7. So for instance, what value here would equal to 7? Well, we know that that's going to be 4 plus 3 equals 7. Okay, so let's just look at this. So find the missing numbers. So if we have 37 plus blank equals 58. So we're just looking to see what that number is. So the way to do that would be 58 minus 37 is what? 21. So the number in there would be 21. 37 plus 21 equals 58. Okay, so what about, hold on. What about this one? What if we had blank minus 15 equals 29. So 29 plus 15 is equal to what? That's going to equal to 44. So 44 minus 15 is 29. Okay, what if we had a multiplication? 4 times blank equals 52. 52. So how do we do to that? If we say 52 divided by 4, we get 13. So 4 times 13 is 52, and so on. So instead of blanks, we could have used letters. So 37 plus x equals 58 would be the same thing. Or x minus 15 equals 29. You could also use A, B, C, D, so forth. It doesn't matter, okay? Just any value. So for instance, if we had x plus 3 equals 7, so if we subtract both sides by 3, we know that x equals 4. And we'll do some more of these in just a minute, okay? So the solution of this equation, what if we had this? 2x minus 9 equals 18. Equals 18. Okay? So if we add 9 to both sides to get rid of that, then we'll have 2x equals 21. Okay? Hold on. That's not 21. It would help if I could add, huh? 27. Divide both sides by 2. You know what? This was not what I was trying to do on this problem. Let's erase this. On this one, we know what x is. So if we have 2x minus 9 equals 18, and x equals 3, okay? So if we put x in here, that's going to be 6 minus 9 equals 18. I'm sorry, this is 18 minus 7x. Okay, so we're going to put 3 in here also. And that's going to be 18 minus 21. So this is going to be minus 3 equals minus 3, just to show you how that works. It's got to equals both sides of the equation. Sorry about that. So solving equations by adding and subtracting. One general rule is used to balance both sides of the equation like we did here. Any operation performed on one side of the equation must also be performed on the other side of the equation. So for example, x minus 4 equals 2. If we add 4 to both sides, that'll go away. X equals 6. That's our solution, okay? So whatever you do to one side of the equation, you need to do to both sides of the equation. So another example would be 12 plus x equals 27. If we subtract 12 by both sides of the equation, that'll go away. X equals 15. Okay, what about this one? A fourth equals x minus 1/2. Okay, so we're going to subtract a fourth from both sides. That's going to go away. So we need to make both of these into a 4. 2 will go into 4 2 times. 2 times 1 is 2. That'll be a 1/4. And when we subtract that, we get a fourth. So x equals minus 1/4. Oops, I'm sorry, that's going to be plus 1/4 because that's minus also. Plus 1/4, okay? So whatever you do to one side of the equation, you have to do to the other side of the equation. Let's do another example. What if we had this? Minus 5x equals minus 25. Okay? Now this one's a multiplication. So when you're multiplying and dividing, the same rule that you do to one side of the equation must be the same to the other. But when you do the opposite, right? So when we had an addition, we subtracted, and when we had a subtraction, we added. So in this case, if we multiply, we're going to divide both sides. So we're going to divide both sides by negative 5. So x in that case is going to be 5. What about this one? 27 equals minus 3x. So this one, we're going to divide both sides by minus 3. So our x is going to equal minus 9. And what about this one? X divided by 3 equals 13. Now this case, we're going to have to multiply on both sides. So we're going to multiply 3 on both sides. See, that goes away. So x equals 39. Okay? Let's do another one. What if we had this one? Again, you're going to have to multiply 6 by both sides. That'll go away. So x equals 36. So whatever you do to one side of the equation, you do to the other side of the equation. Now, what if we have two operation equations? What do we have to do? We've only been doing one step. What if we have to do 2 steps? Okay, 2 steps. So what if we have this? 2x plus 6 equals 14. Okay, so now you need to get x by itself. That's what we're trying to do, okay? So you subtract 6 from both sides. That'll go away. So you're going to have 2x equals 8. Okay, now you're going to divide both sides by 2. That's going to go away. And x is going to equal 4. So that's 2 steps. First step, second step. Okay, what about this one? 3x minus 7 equals 11. Again, we need to get that by itself. So we're going to add 7 to both sides. That's going away. 3x equals 18. Divide 3 by both sides. That's going away. And x equals, that's supposed to be a 3. X equals 6. Okay. Let's try this one. 23 equals 9 minus y third. Again, you're going to get this by itself. You need to multiply both sides by 3. That goes away. That's going to be 42. 42 equals minus y. I skipped a step. Oh, And then we also have to subtract 9 from both sides. So when we do that, you know what? Let's start over. Hold on. All right. So let's do this first. Let's get rid of this 9. So minus 9 both sides. That'll go away. That's going to be 14 equals minus y third. Now let's get rid of 3. 3 and 3. So 3 times 14 is 42 equals minus y. Now, we need to get this y to be positive. So you'll multiply minus 1 by both sides. And when you do that, this is going to be y, and that's going to be minus 42. Okay? Now, what if we have one or more variables that appear? We're going to have to combine the like terms before performing the operations. So what if we have 2x plus 5 plus 4x equals 17? So now look, we have two x's here, okay? So we need to put those together. 2x plus 4x plus 5 equals 17. So 2x plus 4x is 6x plus 5 equals 17. And now we've got it to our normal equation. So we're going to subtract 5 from both sides. That's going away. 6x equals 12. 6x equals 12. Okay? Now we can get this x by itself. Divide both sides by 6, and x equals 2. Okay? Let's look at a couple more of those. So what if we had x plus 2 divided by 3 equals 4? Okay, so we're going to rewrite it. We're going to multiply both sides by 3 to get rid of that. So we got x plus 2 equals 12. Now we can subtract 2 by both sides. That's going away, so x equals 10. Okay, let's do another one. 12 equals 9x plus 4 minus 5x. So again, we need to get these two together, okay? So 12 equals 9x minus 5x plus 4. 9x minus 5x is 4x. So 12 equals 4x plus 4. Now we need to get this x by itself, so we're going to subtract 4 from both sides. So 4 minus 8 equals 4x. Again, we need to get 4 by itself. Divide both sides by 4. And we get x equals 2. Okay? So just on 2 steps, make sure you combine your like terms and then get your x by itself to solve for the problem. Okay? Now, what about practical applications? Let's do an electronics problem. The resistance R in ohms of a particular circuit element is given by the formula. R equals 0.02 T plus 5. Now this is just a formula. T is for your temperature, okay? And we're looking for the resistance. So where T is the temp of the element in degrees Celsius, at what temperature is the resistance? So R equals 5.48 ohms. It gives us that, and we're looking for T. So when you're solving a problem, always write down what you're looking for and what you have, okay? Then write down your formula again. R equals 0.02 T plus 5. We can plug in R, 5.48 equals 0.02 T plus 5. Now, we have it down to how to solve it, okay? So first of all, we need to get T by itself again, okay? So we're going to subtract both sides by 5. That's going away. This is going to be 0.48 equals 0.02 T. Okay? We got to get T by itself, so we're going to divide both sides by 0.02. And when we do that math, we end up with 24 degrees Celsius. Okay? So that's how you work a word problem. Okay, let's try some more problems. What if we had this? What if we had minus 3, y minus 4 equals 36. So now we have these parentheses. So we need to do multiplication across, okay? So it's going to be minus 3y plus 12 equals 36. Now we're back to a regular problem. This is what we're used to, right? So we're going to subtract 12 from both sides. That's going away. Minus 3y equals 24. Divide both sides by 3. That's going away. Negative 3. And y equals negative 8. Okay? And that's how you work those problems. Now, what if we had this one? 8 minus 3, 2 minus 3x equals 34. Again, we need to do cross multiplication here. So we're going to get 8 minus 3 times 2 is negative 6. Negative 3 times negative 3x is going to be positive 3x equals 34. 8 minus 6 is 2. So it's going to be 2 plus 9x equals 34. And again, we want to get this x by itself. So we're going to subtract 2 from both sides. That's going away. So we got 9x equals 32. So we're going to divide 9 by both sides. Now notice we got a fraction form here because 9 won't go into 32 evenly. So let's just make this into a mixed number. So 9 will go into 32 3 times with 5 left. So it's going to be 3 and 5/9. Okay? So just take your time, get it all together, and you'll do great. So now the next thing is multiplying and dividing algebraic expressions. Before we learned that only like terms can be added or subtracted. So that's true. Like terms can only be added and subtracted. If they're not like, then you have to leave them. But multiplying them, you can multiply like or unlike terms. So for example, if you have 2x times 3x, that's going to equal 2 times 3 and x times x. Oh, that's a y there. Times y. So when you multiply that out, that's going to be 6x squared times y. And this one, a times 2a, that's going to be 2 times a times a. Remember, anything a times a is squared, so that's going to be 2a squared. Another example would be 3x squared, y times z, times 2x times y. That's going to be 3 times x squared times y times z times 2 times x times y. We're just multiplying each term. So that's going to be 3 times 2 times x squared times x times y times z. All I'm doing is rearranging it so all the like terms are together. So that's going to be 6 times x cubed, because x squared times x is x cubed, times y is y squared times z. So when you put this together, it's 6x cubed y squared z. Okay? So all I did was take and separate it. 3 times x squared times y times z times 2 times x times y. Then I combine the like terms. 3 and 2 is like, so 3 times 2. X squared times x times y times z. So 3 times 2 is 6. X squared times x is x cubed. Y times y is y squared times z. It's 6x cubed y squared z. Okay? So the rule for multiplication is to multiply numbers written in exponential form having the same base, you add the exponents. So to multiply numbers written in exponential form, xm times xn, they have the same base, you add the exponents. So that's going to equal xm plus n. Okay, so an example, x squared times x cubed equals x 2 plus 3 equals x to the 5th. Another one would be like 4y to the 4th times 6y times y squared. That's going to equal 4 times 6 times y to the 4th times y to the 1, just to show you, and y squared. Okay, so that's going to equal 24y to the 4th plus 1 plus 2. So that's going to be 24y to the 7th. Okay, now for division, you're going to subtract them. So if you had x to the m over x to the n equals x to the m minus n. So for an example, x to the 7th over x cubed is going to be x to the 7 minus 3, or x to the 4th. So 4/5 divided by 4 squared would equal 4 to the 5th minus 2, or 4 cubed. Okay? Look at this one. 6a to the 6th divided by 2a to the cubed. Just kind of divide them out. 6 times a to the 6th and a cubed. That's going to equal 3a cubed, because you're going to say 6 minus 3. Okay? Now, what about negative exponents? Just always remember this. If you have x to the minus n, that's the same thing as x to the n. And this rule is very important for different reasons. But if you can remember that, it'll help you in a long ways, okay? All right. So the last thing we're going to talk about is scientific notation. Scientific notation. So a number expressed in scientific notation when it is in the form of p times 10 to the k, where p is a number less than 1 through 10, okay? And k is an integer. And I'll make sense of this in a second. Okay? So if you had this number, 3,600,000, how do we write that in notation? So we know the number needs to be, p needs to be less than 1 through 10. So where's that number? It's here. So 3.6 is less than 1 through 10. Times, and that's going to be times a million. Okay? So that's the power of 10. So how many zeros do we have? 1, 2, 3, 4, 5, 6 zeros. Okay? So remember that. So that's going to equal 3.6 times 10 to the 6th. And that's scientific notation. Okay? Let's try another one. What if we had this one? 205. So now we need to do a number between 1 and 10. So 20 wouldn't be it, would it? It needs to be 1 through 10. So that's going to equal 2.05 times 10. And then count back. So 1, 2, 3, 4, 5, 6 to the negative 6. So when you're counting this way to the left, it's going to be negative. To the right is positive. Okay? Let's try this one. What if we were multiplying 26,000 times 3,500,000? Whoops. Okay, what if we had that? So let's do the first number first. That's going to be 2.6 times 10 to the 4th times 3.5 times 10 to the 6th. And where this helps a lot is in your calculator. A lot of times it'll cut off these zeros and won't let you put all this in, okay? So that's going to be 2.6 times 3.5 is 9.1 times 10 to the 4 plus 6 because you're multiplying. So that's going to equal 9.1 times 10 to the 10th. And so instead of trying to keep up with all the zeros and figuring that out, you would come better to do it this way so that you don't make an error. Now that's how you multiply. Now how do we divide? So dividing is going to be really similar. 45,000 divided by 0.0018. Okay, so let's put it in that kind of, so that's going to be 4.5 times 10 to the 4th, okay? So, because we're going to put the decimal here, 1, 2, 3, 4. Divided by 1.8, we're going to put the decimal here and count back, 1, 2, 3, 4. I'm sorry, 1, 2, 3, because the decimal's there, times 10 to the negative 3. Now remember, so let's separate this out. It's going to be 4.5 divided by 1.8 times 10 to the 4th divided by 10 to the negative 3. So this is going to equal 2.5 times 10. And then this is going to be 4 minus minus 3. Remember, divide, you subtract, but this is a negative 3 right here. So you're going to equal 2.5 times 10. Plus and a plus is going to add, so that's going to be to the 7th, okay? Because this is going to be an addition there. All right, so that's all you have to do. I will put the last part of Chapter 7 homework problems online today. They'll be due Tuesday, and we'll start with Chapter 8. If you have any questions, please come by and see me. For you guys that are in other areas and not at the Ayers campus, send me an email if you need some help. We can work some problems, and I can meet up with you, okay? Thank you. Have a great weekend.